Have you ever made a layered sandwich or a cake where every layer adds something new? That's exactly how Docker builds your application. At the bottom, you have a base layer or base bread. On top of that, you add sauce, cheese, veggies, toppings. If you change only top layer, you don't have to bake the whole cake again from scratch, right? So Docker images works the same way. Let's understand how. Hello everyone, I am Anjali Shukla. Welcome to PeachyCloudSecurity. Let's get started. So today's objective is to understand Docker images and its layers. A Docker image is like a blueprint or template that we use to create containers. We do not store everything in one blob. Docker splits the images into multiple layers, and each layer is like one step in your recipe. For example, we have a Docker file where we have a base layer, and first instruction as to install curl. Second instruction is to run some command. Third instruction to clean up the cache. Let's say. So there are these layers we have. These are the four layers or the multiple layers we have inside a image. So that's how we create an images. Layer has two important features or two important benefits, I would say. They are cached. If nothing changes in that step, Docker can reuse that layer in future builds. They can also be shared. Many images can use same base layer, saving disk space and network bandwidth. So let's start with our lab and see layers in action. So first of all, we'll create a folder, docker-lab, just to keep everything at one place. Let me do an ls here. Okay, we have successfully created this folder. Next, we'll create a Dockerfile, which is a set of instructions. So first, we have a base layer as Alpine with latest tag. Second, we are running APK update. We are updating it and installing a curl. So as it is an Alpine image, we are using a APK package repository. And last, we are setting a default command, which is curl-help. So whenever I will run this image, it will print the output of curl-help. So let's create this file. Our file is created. Yes, I have a Docker file present. And next, I will build this image. So for that, I will use Docker build -t my curl. So -t we use to give the tag to the image. So here I'm using a my curl and dot because I'm running this command where my Docker file is present. So as you can see, it is building the image layer by layer. First of all, it is working on first layer, which is my base layer and fetching the Alpine image. And second, it is adding or it is updating the image and adding the curl command to it. So we have our image created. Let's run this Docker images command to validate. So here I will use a grep because I have so many images present. I will just use my. So I have my image created, my curl with the size of 16.1 MB. Now I will check its layer. So I will inspect the layer by running Docker history command. So let me run this. Let me clear the terminal. Docker history, Michael. So as you can see, we have this as a CMD that we ran. Then we have a layer, which is APK update and APK add curl. And then we have a second layer, which is a base image. So now if you will notice, I am able to get exact information or exact set of instructions that I have mentioned in a Docker file. I have a Docker image or a container image, and I want to see that how this image was created, and I don't have a Docker file. I will just run Docker history command to check all the layers present in the Docker image. So I have all the layer information in that Docker file. And if you will notice, this information is very crisp and clear that I use an Alpine image. This is the command I use. I am updating it and then adding a curl package, and last instruction I'm using it. curl hyphen hyphen help. So I'll have a clear picture about that image without the Dockerfile just by running Docker history command. Let's run this image and see the output of it. So it is giving me output of curl hyphen hyphen help because that was the instruction that I have passed in CMD. Now we will modify, rebuild the same Docker image just to check that whether the layer is being cached or not. So I will keep my base image as it is. I will use this second layer as it is. I'll reuse this layer, and the change I'm making is here. Curl version. Earlier it was help. Now I will use a version. So you will notice that I am keeping these two layer as it is. I will make change in the Dockerfile first of all. Build my image once again. And as you can see, it is giving me this information that this layer is cached. It means when I first created my image from the Dockerfile, it cached that layer. And as I have not made any changes to that two layers, like the base and the run command I have kept as it is, so it is reusing those layers from the cache. So it saves the time, disk space, network bandwidth as well. So that is why it is very feasible, and it is really a good feature in Docker. Okay, I have rebuilt that image, and now I will see if the image is updated or not just by running a Docker run command. So now I'm getting a different output. It is an output of curl hyphen hyphen version. Earlier I got the output of curl hyphen hyphen L. It means my image is successfully updated. And then it also took a lesser time to build this time, right? Because the image was already cached. So now if I want to scan or if I want to inspect my layer, I have two options. Either I can run a Docker history command to check that, or I can use the dive tool to do that. Let's see how it happens, or it can be done by a dive. It is an open source tool. So let me install the dive first of all. You just have to run a command dive and name of your image, and it will open this kind of a, let me just drag it a little. So you will get this kind of a output or a console look, that in the left hand side we have an information about the layers, that this is my first layer and this is my second layer. You can use an up and down arrow to switch between layers. And the right side, if you'll notice, the information is getting changed. So let's say as of now I am in the left hand side. You can use a tab to change the layers. So if I want to check if anything is changed in the first layer, I can go through it and I can change it. And similarly, I can do it for the second layer as well. And similarly, I can do it for other layers. This tool is really good when you have a multiple set of instructions present in the same Docker file and you are scanning an image. You can press Control C to come out from this. So this is a tool dive that you can use to inspect your layers, or you can use a Docker history command to inspect your layers. Next, we have an optional method. If you want to push this image to a Docker Hub, which is a public repository, you can first of all tag this image. So whenever you're pushing an image to your repository, you have to change the tag of that image. So you have to write your Docker Hub username / my curl is a name of a repository that will be created on a Docker Hub, followed by a tag name. So you can first of all change the tag of your existing image. As of now, my image is having a my curl tag. I will change it to my Docker name, Docker Hub username / my curl :1.0, and then I will just push that image to my Docker Hub. Initially, you have to log in at last for your username and password. So in this video, we have seen how to inspect each layers, and it is really helpful at the time as a security engineer when you are inspecting those images and you have a multiple images and you have to check or you have to validate any false positive or a true positive. So that was it in this video. I'll be back again with other video on Docker because we are learning about containers and its security. So stay tuned for more videos and do subscribe our channel. Thank you so much.